All right, so what we've got is two different book clubs. You guys have already read, so you know this. We got two different book clubs that charge a different amount. And we want to convert this into an equation. So we know that ABC Book Club charges $40 a month plus $2 per book read. Now, $40 per month is a flat fee. That does not change. So every month I'm going to have to pay $40 plus. Well, the amount I pay extra depends on the number of books I read. So it's $2 times the number of books, and X is going to represent the number of books. Easy Book Club charges $35. That's my flat fee. And then the amount extra I'm charged is going to be $3 per book. So this one, it costs less to begin with, but it costs more for each book. So at a certain point, these could even out. So the way that we figure out where that number is we just take these two different expressions and we set them equal to each other. What value of X will make the cost of ABC Book Club be the same as the Easy Book Club? So if we set them equal, we can just solve it from here and find that out. So I will go and do that. Subtract 35 from both sides. So I get 5 plus 2x equals 3x. Now I want to get all my variables to the right. So I will subtract 2x from both sides. That cancels out. And 5 equals x. It looks like if you buy 5 books, then you will pay the same amount. And beyond 5, one of them will cost more than the other. And less than 5, the other one's going to cost more. And you can kind of think through that. That's not part of our question, but you can mentally think through which one would cost more at different levels. But at 5, they cost the same. And that's the whole idea behind this problem. So today we are going to be looking at quadrilateral properties a little bit more, and parallel perpendicular lines, rectangles, parallelograms, all that fun stuff, and we'll jump right into that. But so this is the list of quadrilateral properties. Again, I kind of bolded ones that were more important, and here's what we have is that sides meet at a right angle for a rectangle. That is the defining characteristic of a rectangle, and that's going to be the main thing that we look at for today. All right, so another thing that we will talk about a little bit is that opposite sides of a parallelogram are parallel. This is going to be a minor concept, but it is going to still be an important one. All right, so let's just jump into this real quick. And I will remind you of those particular properties when we get back to them. Before we can jump into actually messing with the quadrilaterals, we need to know a few things about parallel and perpendicular lines. We already know that parallel lines never intersect. Now on a graph, that means that the slopes of the lines are equal. Okay, and we need to remember something about slope. We have our standard slope formula, y equals mx plus b, or my slope-intercept form of a linear equation is the way to say that. This is your y-intercept. We don't care about the y-intercept today, so if we see any equations, the y-intercept doesn't matter to us. The slope, though, that matters. So if we are given an equation, we want to be able to look at the equation and be able to identify what the slope is. Now, it's actually not going to be a big part of our class today to see this kind of an equation, but this is a reminder and just brief review about it. So if I come down to this problem, I can see that the slope for each of these is 2. It's that number right in front. So if the slopes are equal, so if the slope of the first one equals the slope of the second one, then therefore, that means therefore they are parallel. So that's good. It's actually pretty simple. No calculation required if you see the equations. All right. Now, perpendicular is slightly less straightforward, though it isn't too bad. Perpendicular lines intersect at 90 degrees, and we already know that as well. In fact, we created a perpendicular bisector, and we looked at some other situations of perpendicular lines when we were looking at our unknown angle relationships. So there are perpendicular lines, and on a graph, we need to actually do a little bit of calculation. And we had to take the slopes of our two lines and multiply them. If the product of those two slopes is -1, then they are perpendicular. If it's anything else, even if it's like -99/100, if it's anything else, then they are not perpendicular. Okay. All right, so now we can see 3 different examples right here. And in these 3, we actually do have the slope equations given to us. In a little while, we're actually not going to have these equations given, and we'll see how to work with that. But I can see that my slope for the first one is -4/3. And the slope for the second one is 3/4. So I can just multiply those together. So I'm going to do -4/3 times 3/4. And when I multiply across, keep in mind if you have a negative, that can just be attached to your numerator if you like it that way, or the denominator. So I'm going to make it -4 times 3 makes it -12. And then it'll be +3 times 4, which makes it 12. And when I simplify that down, it's -1. So therefore, these are perpendicular. All right. The next one, now if we look at the next one, you probably already are seeing like, that doesn't look perpendicular. It doesn't look perpendicular, but we can verify whether it is or not. So my first slope is going to be that when you just see the -x, remember there's always an invisible 1 out in front. So that's -1 for the slope. My second one is right here, 1/2. So at this point, I can multiply them together. -1, let me write as -1/1 times 1/2. And multiplying across, I get -1/2. Okay, that is not -1. So therefore, we can say that these are not perpendicular. They're not parallel, they're not perpendicular, they're just 2 intersecting diagonals. All right. Now the last one, we can already see it shows the right angle here. So we know from the get-go that it's perpendicular, but let's just verify it. So we got 3 and -1/3. So I'm not going to write the slope separately. I'm just going to write it this way. 3 times -1/3. And remember, if you have just a number, you can always put the number over 1. So that makes it a little easier to do this multiplication. We don't have to think as hard. Multiply your numerators going across and you get -3. Multiply your denominators, you get 3. Remember, you just multiply across like this and then multiply across like that. And you get -3/3, which simplifies down to -1. These are perpendicular. Okay, very good. That's really all there is to finding out if 2 lines are perpendicular to each other. So it's a little bit more involved than parallel, but it's not that bad. All right, let me clear this real quick. And I'm going to take you over real quick to Delta Math. I wanted to show you guys, let's start with, okay. All your problems are going to be types that look like this. And this looks a little bit challenging at first, but all you have to do for these types of problems is pick anywhere you want on the graph. It doesn't matter. I'm just going to pick this spot right here. And I'm going to start trying to figure out what the slope of this is. So is that it? It's not quite there. Okay, it looks like there works. And you'll notice, look there, it's like this dashed gray line. When I move it to right here, it becomes this green line. And that's going to let me know that it's either parallel or perpendicular. So you will need to read the problem. Is it asking you to find a parallel line or a perpendicular? This one says parallel. So we're good to go. I'm feeling good about that. And now it wants me to write down the original slope and the parallel slope. So the original slope comes from the blue line. And for that, I can just pick any point that it passes through, and then any other point that it passes through. And I want to find the slope of it. Remember, your slope is rise over run, not rum, run. And your rise over your run is your change in your y value over your change in your x. That's what that triangle means. It means change in. So here, I will start with my change in y. So I'm going to start at this point right here, and I'm going to go down. It looks like I had to go down 4. So -4 in the y direction. And then from there, I can go +2 in the x direction. We already talked about the plus and minus in the x and y direction whenever we were looking at translations. So you should be familiar with this already. So I'm going to go -4 in the y, +2 in the x, which means my change in y over change in x is going to be -4 over 2. And I can simplify that down to -2. So my original slope is -2. My new slope, well, if I look at this one, I'm going down 2, so -2, right 1. So it's going to be -2 over 1, which is -2. So it's the same thing. So you don't have to write out all this work when you're doing this work individually. On the test, I'd want to see some kind of work to show how you got this. But if you understand it and you can quickly identify it, that's good. That means you're getting the hang of it. So I'll submit this, and I got a check mark. Good for me. So now let me try a different problem. This is going to be one where we're going to look at perpendicular lines. Okay, and now we still have, notice it says right here that it's perpendicular that we're looking for. So you will have to read, because this will be randomly assigned to you. So you get a mix and match. You need to make sure you read correctly, or else you'll get it wrong. All right, so I've got this point right here. I could look and figure out the slope, but I could also just play around with it until, oh, I saw something green. There it was. So there's green. And it's going to let me know when I've got perpendicular lines. So we're good to go with that. I'll just call it good. So now I need to figure out the slopes of this. So the original slope is from the blue line. And if I look at that point right there, and it looks like it passes to this point right here, I went down 3, and then to the right, 2, 4, 6. Now, as far as finding those points, that might have been something I just did really quickly. There are a lot of points this passes through. I can see one right here, 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 and you can see all the different points. Now, I could have picked any 2 of those. I just picked 2 that I saw. And then I just connected them together, and I wrote out what the change was. So my slope for this one, I'll just say my slope for my original is going to be -3, which is in the change in y, over 6, +6, which is my change in x. So now I can simplify this. And if I simplify that down, I can divide both sides by 3, both the numerator and denominator by 3. So that gives me -1 over 2, -1/2. All right, let me put that in as my original slope. And the way that this works on Delta Math, whenever you type in -1, you have this slash where your question mark is, if you're looking at a regular keyboard. So whenever I hit slash, it's going to automatically turn that into a fraction for me. And there we go, -1/2. All right. So now if I look at the other, I have this point right here in yellow and this one in yellow. My change in y is going up 4 and then right 2. So +4, +2, which means my slope for number 2 is going to be 4 over 2, which becomes just 2. So I don't have to do anything fancy for that one. So at -1 and 2, when I submit this answer, okay, it looks like we did it right. And if you don't get it right, let me clear this all off the screen. It will show you your slopes and it'll show you the graph. So it'll show you what it should have looked like. Now, it might not show the perpendicular line exactly where you drew it, but the exact perpendicular line doesn't matter for right now. We just care about the slopes. So there it is. And you can even see right there, many possible perpendicular lines could be made, but they'll all have the same slope. Okay, so are there any questions on this part of it? Do you guys want to see another example or anything else? Okay. If you do need to see more, if that is not making sense completely, feel free to stick around. More than happy to go through that some more. Now, this is going to be half of your homework. You will have to go to Delta Math and do 5 of these types of problems, and it's going to be randomly assigned. So you could get 3 of one type, 2 of another, 5 of one type. I don't know what it's going to look like for you. Okay, let's finish up with this. Now let's go back to our quadrilaterals. Okay, so the question that we're going to ask is this a quadrilateral or a parallelogram? There's another question, is it a rectangle or a parallelogram? So let's answer the first question. You won't actually have to answer this on your homework tonight, but it's worth looking at. Now, one thing we know about parallelograms, and we did this last Thursday and Friday, is that the midpoints should be the same. We're not going to test it this way. We're going to test this a different way. I'm going to test to see if the opposite sides are parallel. So I will find the slope of all 4 sides. So going from A to D, my slope is down 3 and right 7. You can count that up, but you can see that's my slope. So my slope for this one is -3. Oops, sorry about that. -3 over 7. So if I go to the opposite side, I'll go down 3. That's good so far. Right 4, 5, 6, 7. Right 7. Which this also gives me a slope of -3 over 7. All right, so the opposite sides here so far are parallel. They have the same slope. So I will put those arrows there to show that they are parallel. So now I need to do the other 2 sides. All right, so now I'm going to go from B over to A. And that means I'm going to start by going up. How much is that? 1, 2, 3, 4, 5, 6, 7. So plus 7. And then right 3. So this is a slope of 7 over 3. Remember, it's your y, your rise, over your run. Let me make that clearer. All right, now the last one I need to do is going from C to D. So I'm going to go up 7. I was counting it up real quick. Up 7, right 3. All right, and when I do that, that also gives me a slope of 7 over 3. So these 2 are also parallel. So at this point, I've determined these are parallelograms. Parallelogram, okay. There we go. Parallelograms. There, I spelled it right eventually. All right, and not parallelograms, it's just a parallelogram. Okay, we get the idea. So now the question, and I might clear this, well, I don't want to clear it off completely, but I'm just going to focus on this side, right? Let me change the color real quick so I can highlight what I'm doing. I'm going to look at this side right here, and I'm going to look at this side right here. I want to look at only the adjacent, any 2 adjacent sides. It doesn't have to be those 2. Any 2 adjacent sides, I want to look at those 2. And now that I've found those 2 that works, I want to find out if they're perpendicular. So I'm going to multiply the slope by the slope and see if I get -1. That's my -7. All right. So my slope here, I was jumping ahead because I have a 7 I'm about to write. Let's say that I'm going to multiply that slope and that slope together. So I'm going to have negative 3 over 7 times 7 over 3. So that gives me negative 21 on the top and then 21 on the bottom. I'm going to multiply across like this. And that gives me negative 1. So it turns out these are perpendicular, which means it meets at a 90-degree angle and it meets the definition of a rectangle. All right, any questions on that process I just went through? I am going to do another one, but does anyone have any questions right now? Okay, so this one right here, the same questions as before. Is it a quadrilateral? Is this quadrilateral a parallelogram or not? We can figure this out real quick. I'm just going to run through and all right, I've got plus 3. And what is that? 2, 4, 6, 8, 9. That's plus 9. So I'm going to write this a little clearer. That is, so my slope here is going to be 3 over 9. I could simplify that. I'll worry about simplifying in a second. Let me just see this. So this is up 3 again. I'm going to go from B to C. I'm looking at this side right now. So I'm going up 3, right 9. To go from B to C, I'm looking at the opposite side. So the slope here is also 3 over 9. Okay, we're good on that. So these two are parallel. Now, going from A to B, I'm going to look at the side on the left. I go, first of all, down, how much is that? 2, 4, 6, 7. So that's minus 7. And then I'm going to go right 2. So that gives me a slope here of negative 7 over 2. Going from D to C, I'm going to go down. That looks like 7 also. Right 2. And that gives me a slope of negative 7 over 2. Hey, the left and the right have the same slope, so these are parallel. So is it a parallelogram? It is a parallelogram. I'm not going to try and write that again. I messed it up the first time, but it is. Okay, so now the only question is it a rectangle or a parallelogram? All right, so for a rectangle, I want to see if these corners are 90 degrees. And the only way I can figure that out is by multiplying the slope of 2 adjacent sides. So I'll pick this side right here. And just to show it doesn't matter, I'll pick this side over here. Any 2 adjacent sides will work because if it's not a parallelogram, it's not a rectangle. So we don't even need to bother going on if it's not a parallelogram. All right. So if I look at this, I've got a slope of 3 over 9 and negative 7 over 2. So 3 over 9. And again, I could simplify that, but it's really not that big of a deal. Negative 7 over 2. What matters, this would matter in certain situations, but for right now, the only thing that matters is what the product of these two will be. So anyways, I've got 3 and negative 7 multiplied together gives me negative 21. 9 and 2 multiplied together gives me 18. This could be simplified. I could simplify this down to negative 7 over 6 because these are both divisible by 3. All right, but here's the key thing for this particular problem. It's not negative 1. This does not equal negative 1, so therefore it is not perpendicular. And when it's not perpendicular, it is not a rectangle. It has to just be a regular old parallelogram. Now, I can't just look at that and determine right off the bat that it's not a parallelogram. Or that it's not a rectangle. It kind of looks like one. So for this one, I would need to do the math in order to figure that out. Okay. Again, if you need help with that, you can ask any questions. You can stick around afterwards and we can go through more. So if I come over here to your Delta Math, not Delta Math, sorry. this is your homework for tonight. It's just another PDF of a few problems, and you need to do all the even problems. So make sure you're aware of that. There's going to be only 3 problems as far as this goes. And here's what you need to do. Notice that all these have the same instructions. Determine if the quadrilateral is a rectangle or a parallelogram by determining whether the adjacent sides are perpendicular. It doesn't matter if you can look at it and decide it's a rectangle or not. You need to do the math. So you need to find the slope of this line and this line. And really that's it. Because that's all I'm asking you to do for this particular problem. If you want to verify that they're parallelograms, find the slope for all 4 and see if the opposites are the same. But the main thing is that you want to make sure that you get 2 of these adjacent sides, the slope for it, multiplied together. If it's -1, it's a rectangle. If it's not -1, it's not a rectangle and it's just a parallelogram. So go through and do that. You'll need to submit your work. Remember, you submit your work down at the bottom by hitting submit assignment, and you can put, oh, number 2 is a parallelogram. I might put, oh, negative, you can put in the slopes. I'm making stuff up. -3/7 times 6/3 equals -18/21, and therefore it is not a rectangle. It's just a parallelogram. So, I mean, something like this really gets the point across. I can see what you did. It makes sense to me. All right. So if you have questions on just about anything related to geometry, please stick around. Otherwise, you can have yourself a wonderful day, and I will see you tomorrow.